to design the structure. In unit number 2, we have to focus on design philosophy, how to design the structure if the structure is pre-stressed. Now that may be beam or that may be slab. Now we will start with the beam. Chapter number 1, it is for the design of beam. In that, initially we will see flexural strength of PSC rectangular section. So initially what we will do, we will discuss about how to design the rectangular section. How to design the rectangular section. How to design the rectangular section. Now for any section, it may be your RCC structure or it may be your PSC structure. So the important concept about the stress block. Now this is the stress block for the pre-stressed concrete. And so on that particular section, what is the moment of resistance? How much movement will be resisted by this particular section, that we have to discuss. And this will be same on the same line as that of the RCC. In RCC also, we have seen the design of beam. We have seen the flexural strength of RCC rectangular section also. For that we have used IS 456. Now for PSC we have to use IS 1343/2012. Now this IS code, it is uploaded on the Moodle, so you can download that PDF and you can refer, or you can refer all the clauses in that IS code. Now this is the rectangular section having the cross section B into D. Okay, this is the cross section. And this is the location. This is the location of the tendon. This is the steel, pre-stressed steel. That maybe you can say tendon or the cables on this pre-stressed structure. So this is the location of the steel, and this is the effective depth. This is the effective depth, small d, and the overall depth of this particular section, we can say that is the capital D. Then the effective depth, it will be small d. And how to find out that effective depth? So overall depth minus cover minus 5/2. Okay, so that you will get the effective depth is small d. So the cross section is B into D. Then the depth of neutral axis. Now this line, it is the neutral axis. So this particular section, it is nothing but the neutral axis. So this is the location of the neutral axis. Now the depth of that neutral axis, it is XU. So that XU, it is nothing but the depth of neutral axis. Now, as this is the combination of concrete and this pre-stressed steel, high tensile steel, so these are the forces. These are the two forces. So we can say it will form the couple. Now this is the force due to the concrete. This is the force due to the steel. Okay. So for concrete, the force will be what? 0.36 FCK B into XU. This is the force. These are the forces, we can say. This is the force due to the concrete. This is the force due to the steel. And these two forces, it will form the couple. Now, if these are the forces, and if you have to find out the moment, then we know that if there is a couple, two unlike parallel forces separated by certain distance d, and that certain distance d, it is called as the lever arm. So for this case, the lever arm, suppose this is the total d. Okay, this is the d, and this is the depth of the neutral axis. Then the lever arm, this particular lever arm, if you have to find out, so that will be d minus 0.42 XU. Okay, so location from the top for that particular force due to the concrete, it will be 0.42 XU. This particular lever arm, so that distance will be what? This total depth d, this d minus this particular 0.42 XU. So that you will get this lever arm. So that d minus 0.42 XU, it is nothing but the lever arm. Okay, now this is the, we can say, perpendicular distance. This is the perpendicular distance. Now what we want? We want the moment. Now for the moment, unlike parallel forces, I think, moment काय असेल? Force into perpendicular distance. मग perpendicular distance आपण हे find out केलं, ते काय असेल? This effective d minus 0.42 XU. Now this is the distance. And what is the force? So for steel, the force will be this FPU into AP. Okay. Now what is that force? This is the final tensile force of the cable at failure. and the area of that pre-tension cable is AP. Okay. Now that force into perpendicular distance, we will get the moment of resistance. Means if the section having the cross section B into D, having the cross section B into D, practically you will get certain value 230, 400 likewise. So moment of resistance for that particular section, it is given by this particular formula. It is given by this particular formula where D is the effective depth, where XU it is the depth of the neutral axis. Okay, where APS it is the area of pretension steel, area of pretension steel, and where FPB it is the stress, it is the, we can say, tensile stress of cable at a failure. So using this, we will get the moment of resistance. This is the formula we have to remember. Now all that term where MU it will be moment of resistance. P of bit is the tensile stress in tendon at failure, at failure. Okay. And FP it is the effective pre-stress in tendon. This is the area of pre-tensioning tendon. D is the effective depth and X it is the depth of neutral axis. So this particular formula we have to refer. So what is the moment of resistance? So it is the bending moment resisted by that particular section due to its dimension. Bending moment due to the external load, it is resisted by that particular section. Now if you see that section, the section is rectangular. Now if the section is rectangular, so due to certain loading condition, we are providing the dimensions and we are providing the steel. How much movement will be resisted? How much movement will be resisted for this particular rectangular section? It is given by this equation. Okay, PA in bracket D minus 0.42 XU, moment of resistance. Now there is a ratio called as the effective reinforcement ratio. Now how to provide this steel? How much area is provided? Okay, how much area of steel is provided? So for that we have to refer the table number 11. Table number 11 in IS 1343. So in case of RCC, means your SD2, in case of RCC, so what was the percentage of steel we are providing in case of slab? In case of slab, how much percentage of steel we are providing? So that percentage it was different for beam, that percentage it was different for the columns, and for slab also it was different. For slab, it was 0.42. Just a minute. So in case of slab, for HYSD steel, means for the diameter more than 6 mm, we are using 0.12% of the gross area. Then for mild steel, we are using 0.15% of the gross area. Now these are the values for the slab. Then for the beam, the maximum tensile reinforcement we are provided as 0.04 gross area B into D. 0.04 B into overall depth D. Then in case of column, we are providing the 0.8 to the 6% of the area of steel, AST percentage. Now here in case of pre-stress, we have to use the table number 11. In case of pre-stress, we have to use the table number 11. Now see the heading of table number 11. So what this table indicates, this is the conditions at ultimate limit state for rectangular beam with pre-tension tendons or with post-tension tendons having effective bond, having the effective bond. Means this table it is valid for pre-tensioning as well as bonded post-tensioning tendon. Okay. Now if you see this particular first column, it is for area, then it is its tensile strength divided by BD into FCK. Now this particular ratio, it is called as effective reinforcement ratio. It is called as the effective reinforcement ratio. Okay, because if you assume this ratio, and the value of that ratio, the minimum it is 0.025 and the maximum it is 0.40. Now these are the two values. You should know what is the minimum value and what is the maximum value, and this is IMP. This is IMP for ऑल द कॉम्पिटेटिव्ह एक्झामिनेशन्स. आता तुम्ही बी ला आहात, गेटचा फॉर्म तुम्ही भरला असेल, गेटचे फॉर्म आता निघालेले आहेत, बरोबर आहे. सो इन गेट एक्झामिनेशन ऑल्सो देर आर वेटेज ऑफ 4 to 5 marks on the pre-stress. Now, as for your gate examination point of view, you should know what is this table is all about and what are the variation of that ratio, how that variation is there. Now, minimum the value is 0.025 and the maximum it is 0.04. So this is the variation. This is the variation. And this particular ratio, it is the effective reinforcement ratio. Then, so what they have given? They have given the stress in tendon for that ratio. They have given the stress in tendon as proportion of design strength. So stress in tendon as a proportion of design strength, that is PFB divided by 0.87 FPU. Okay. And they have given for the pre-tensioning as well as bonded post-tensioning. And they have given the two columns, that stress in the tendon. Okay. Similarly, they have given the ratio of depth of neutral axis to that centered of that tendon. So means they have given the value of XU by D. They have given the value of XU by D. Means what? So initially we have to assume this particular ratio. So once you assume that ratio, we are using the effective reinforcement ratio, say 0.10. Then, so you can get the XU by D as 0.217. If I assume the ratio as 0.10, I will get the XU by D as 0.217. And if I assume the D, I will get XU. Depth of neutral axis I will get. So from that, I can work out for the moment of resistance. So first point, this is the effective reinforcement ratio. And the ratio it is varying. The minimum is 0.025 and the maximum is 0.4. Okay, so this is the variation. So corresponding stress value they have given for pre-tensioning and bonded post-tensioning. And they have given the depth of neutral axis also, XU by D ratio also they have given. Okay. So this table is very much important. Now based on that, so n number of questions can be asked in various examination. Now this is the question asked in MPSC. This is the question asked in MPSC 2007 mains examination for 2 marks. Now, what is the question? The maximum effective reinforcement ratio. The maximum effective reinforcement ratio of bonded pre-stress concrete beam at failure according to IS 1343 is limited to a value. Okay. So what is the maximum reinforcement ratio, effective reinforcement ratio they have asked? Now we will go back to the table. Now after seeing this table, what is the value? Maximum reinforcement ratio. किती असेल? See the table. This is the reinforcement ratio.
0.4.
Yes, 0.40 or 0.4. So this is the maximum value. पण आपल्याला व्हॅल्यू लक्षात ठेवायच्या आहेत. सगळ्या व्हॅल्यू लक्षात ठेवायची गरज नाही. बिकॉज फॉर डिझाईन इन कन्व्हेन्शनल पेपर you are allowed with IS code, but in competitive examination where IS code is not allowed, the extreme values are important. Minimum and maximum. They will not ask the in between value. They will ask the minimum value and the maximum value. So the maximum is 0.40. Okay. So this was the question asked in the MPSC examination. So the correct answer is option 2. Okay. Now we will discuss some 3 to 4 MCQ on unit number 1. Simple MCQ. Pre-stressing force transmitted to the concrete as initial internal stress to counteract the internal stress developed to the external load is called. Okay, pre-stress in a concrete as an initial internal stress. So to counteract internal stress developed due to the external load. So this concept is stress, strength or load balancing concept. So in unit number 1, we have discussed this. So this particular concept, it is called as the stress concept. So whenever you are counteracting the initial internal stresses of the section due to the external load. That is the stress concept. That is the stress concept. Okay. Means total section it will behave as an elastic one. Total section it will behave as an elastic one. Next, it is on the losses. The approximate value of shrinkage strain. The approximate value of shrinkage strain for design of PT member is, where T is age of concrete. T is the age of concrete. So shrinkage strain they have asked for post tensioning member. Post tensioning member. So in case of losses, we have discussed this. Now they have given T is the age. T is the age of concrete at a transfer in a days. Means your option should be from 1, 3, or 4, isn't it? So for post tensioning, the shrinkage strain it is given by 0.0002 divided by log 10 of T plus 2. Correct answer is option 3. Option 3 is the answer. Option 3 is the answer. Now, so 0.003, this is the shrinkage strain in the pre-tensioning. This is the value for the pre-tensioning. Pre-tensioning. And whereas 0.002 divided by log 10 T plus 2, this is the value of shrinkage strain in post-tensioning. In post-tensioning. Now, if you have to find out the shrinkage strain, so E into shrinkage strain, you will get the corresponding loss. Now, these are the two values. So for that, we have to refer IS 1343 and you have to read all the clauses. Vyavasthit vata IS code. All the clauses corresponding to the syllabus we have to read. Okay, and we have to understand. Yes, in pre-stress concrete beam, ratio of applied pre-stress force to the concrete capacity of section in compression is known as ratio of applied pre-stress force to the capacity of section is known as, yes, table number 11. Table number 11. So in table number 11, which concept we have discussed? That is APS into FPU divided by BD into FCK. So this particular ratio, it is the ratio of applied pre-stress force to the capacity of section. मग याला काय म्हणलं होतं आपण? Yes. काय म्हणलं होतं याला? That is effective reinforcement ratio. So here, so the answer is option 3, reinforcement ratio. So as per the clause, this is the effective reinforcement ratio. Effective reinforcement ratio. Option 3 is the answer. Now in high tensile bars. So this is the MCQ from the pre-stressing methods. So there are 4 to 5 pre-stressing methods generally used for the tensioning of the cables. Now whenever we are providing the thread, so whenever we are providing the threads, so we are tensioning this particular cable. So what we are doing, so at end it may be fixed, at other end. So what we are doing, one end suppose it is fixed and at other end we are giving the tensioning. So after tensioning we are providing the thread. Okay, and we are putting the bolt over here. So that initial length it will be L. After tensioning and fitting with the bolt on that thread, so that length it will be say L plus L dash. So that L dash it is the tensioning we are providing on that particular cable. So this particular system it is used in Lee McCall system. Okay, so here the correct response is option 3. Means bars are threaded. High tensile bars are threaded. Means the cables are threaded. एक एंड फिक्स करायचं असतं केबलचं आणि दुसऱ्या एंडला टेन्शनिंग द्यायची. मग टेन्शनिंग दिल्यानंतर काय करायचं, थ्रेड्स असतात त्याला बोल्टनी फिक्स करून टाकायचं. दॅट इज द टेन्शनिंग. सो दीज आर द सिम्पल MCQs. And for your unit number 1, your unit test 1, it will be on your syllabus up till now. म्हणजे आज जेवढा सिलेबस होईल त्यावरती तुमची युनिट टेस्ट असेल. आय विल प्रोव्हाइड द क्वेश्चन बँक ऑन Moodle. Okay. So here response is option 3. Now we will discuss one numerical. So this is the numerical on the to find out the moment of resistance for the rectangular section. Now here the pre-tension pre-stressed concrete beam having the rectangular section 150 wide and 350 deep. Okay, so the rectangular section is given 150 wide, 350 deep, has the effective cover of 50 mm. So the effective cover, it is 50 mm, and the FCK, it is 40 MPa, and the FP they have given 1600 MPa, and the area of pre-tensioning steel, it is given as 461 mm square. Calculate ultimate flexural tensile strength of the section. Now we know what is pre-tensioning, we know what is post-tensioning. So what is the minimum grade of concrete? What is the minimum grade of concrete for pre-tensioning? What is the minimum grade of concrete for pre-tensioning? 30 or 40? M30 or M40? किती असेल प्री टेन्शनिंग साठी?
M30.
M30. बर, पोस्ट टेन्शनिंग साठी? पोस्ट टेन्शनिंग
M40.
M40. So for pre-tensioning, it is M40. Okay, उलट सांगितलं होतं. And for post tensioning it is M30. Okay, pre-tensioning, so when we are giving the tensioning first, then concreting, whereas for post tensioning we are doing the concreting first, then we are applying the tension on that cable. So that's why grade of post tensioning it is less as compared to the pre-tensioning. So for post tensioning M30, pre-tensioning M40. Okay, so these are the minimum grades. And what is the maximum grade for both the cases? Minimum grade माहिती आहे आपल्याला 30-40 असतं. Pre साठी 40, post साठी 30. So the maximum grade for both pre-tensioning as well as post tensioning is M60. So for that, refer the IS code. So in IS code they have given all the clauses, so you have to read all the clauses correctly. Okay, so the minimum M40 for pre-tensioning, M30 for post-tensioning, and the maximum it is M60 for both the cases. So we have to find out the ultimate flexural tensile strength, means we have to find out the moment of resistance. Now all the parameters they have given to find out the effective reinforcement ratio. Now here the effective reinforcement ratio, the formula is known to us, table number 11 of IS 1343. So the PF into AP. So this is the tensile strength of the cable. This is the area of that tendon divided by cross section BD into the grade of concrete. So FP they have given 1600. Then area they have given 461. So the cross section they have given 150 into 350. But this is the overall depth they have given. Okay, 350 it is the overall depth, and they have given the effective cover of 50. So the effective depth D, it will be overall depth minus effective cover. So overall depth it is what? 350. So 350 minus cover, that is 350 minus 50, 300. Okay, so FCK grade they have given as M40. So after putting this value, so the effective reinforcement ratio we are getting 0.40. So from table number 11, so what we have to find out? We have to find out that neutral axis depth or depth of neutral axis. So that ratio we want XU by D. Now for that, one of the thing that we should know. So what we have found out? We have found out that effective reinforcement ratio, and that is 0.4. Now corresponding to that 0.4, so what parameters we are getting? So that stress value we are getting as 0.9 and the depth of neutral axis we are getting as 0.783. ह्या दोन व्हॅल्यू कुठून आल्या? टेबल नंबर 11. Now we will again go back to the table number 11. If you see this table number 11 here, okay, so for table number 11 you have got the effective reinforcement ratio. You have got the effective reinforcement ratio as 0.4. Now the values corresponding to 0.4, the values corresponding to this 0.4 for pre-tensioning, it is 0.783. This is for the depth of neutral axis, and for the stress in tendon the ratio is 0.9. So 0.9 and 0.783, it is from this table number 11 corresponding to the effective reinforcement ratio of 0.4. Okay. Now once you get XU effective depth, so we can find out the ultimate tensile strength. Okay. So using these values from the table number 11, now you can get the ultimate tensile strength of that cable. So as this ratio is known to us, this is 0.9. So ultimate tensile strength of the cable, it will be just cross multiplication. So the initial tensile strength they have given for that cable, that is 1600, 0.87, that is the factor of safety for that steel. And this is the 0.9, this is the stress in tendon from the table number 11. So if you do this calculation, so the ultimate strength at failure, it will be 1253 Newton per mm square. Then for depth of neutral axis, so this ratio is known to us, that is 0.783. So if you want XU, so that will be 0.783 into the effective depth, that is 300. So we will get the effective depth as 234.9 mm. So this is the depth of neutral axis from the top, and the moment of resistance or the ultimate tensile strength, it is given by the formula PFU, that is the ultimate tensile strength at failure, area of pre-tensioning cable into lever arm, and that lever arm is D minus 0.42 XU. Now in this formula we know all the corresponding terms. PFU माहिती आपण फाइंड आउट केलं, एरिया 461 ऑलरेडी दिलेला आहे, इफेक्टिव्ह डेप्थ इज 300 minus 0.42, depth of neutral axis just we have calculated 234.9. So after this calculation, so the moment of resistance or ultimate tensile strength is 116 kilonewton meter. Okay, so this is the moment of resistance for the rectangular cross section. Now practically, if the load is more, we are going to provide the flange section also. So everywhere we can't provide the rectangular section, we have to go for the flange section also. Means that may be our T section, that may be our I section. Okay, so that is the next point we will discuss in the next session, how to find out the moment of resistance. So what are the terms or what are the different calculation philosophy in finding out moment of resistance for the flange section. Now for your unit test, the syllabus will be unit number 1, total syllabus, and from unit number 2, the point will be, so what we have covered in the today's session, it will be there, that is moment of resistance. Means MCQ will be there on this particular formula. Okay, MCQ will be there, or the question will be there on the MCQ that we have discussed. So again, I will show you that MCQs. So these MCQs, these 5 MCQs will be there for unit number 2 in your unit test number 1, and unit test 1 will be on your Moodle. ठीक है, सगळ्यांचा Moodle login check करा, your unit test 1. Hence onward, all the test assignment will be conducted or assessed on Moodle platform only. तुमचं लॉग इनचा काही इश्यू असेल तर मला तुमचं नाव, डिव्हिजन, रोल नंबर फक्त व्हॉट्सअप करा. आय विल सॉल्व दॅट इश्यू. सो वन्स यू लॉग इन द Moodle पेज, एक्झाम कशी असेल तुमची युनिट टेस्ट, यू हॅव टू लॉग इन द Moodle पेज. ओके, तुम्ही जेव्हा Moodle पेज लॉग इन कराल तुम्हाला सब्जेक्ट दिसतील, 5 सब्जेक्ट दिसतील. TRE असेल, SD3 असेल, you will get all that 5 subjects. Suppose tomorrow is TRE unit test. So what you have to do? You have to log on to the Moodle. You have to log in to the Moodle. Moodle ला लॉग इन करायचं आहे. त्या सब्जेक्टवर क्लिक करायचं आहे. TRE सब्जेक्ट वरती क्लिक करायचं आहे. त्यानंतर तिथं अनाउन्समेंट असतं. सब्जेक्टच्या सगळ्यात वरती जी सेक्शन असतं दॅट इज अनाउन्समेंट. ठीक आहे. सो अनाउन्समेंट सेक्शन मध्ये तुम्हाला एक लिंक दिसेल. लिंक काय असेल? युनिट टेस्ट 1, UT1, TRE, त्या सब्जेक्टची युनिट टेस्टची लिंक तिथं असेल. पण ती लिंक कधी क्लिक करायची? ॲज पर युअर युनिट टेस्ट शेड्यूल. ठीक आहे. जेव्हा तुमचं शेड्यूल असेल तेव्हाच क्लिक करायचे. अगोदर केलात तर ते तुम्हाला क्वेश्चन पेपर दिसणारच नाही, कारण रिस्पॉन्स बंद असते. त्या लिंकवरती क्लिक केल्यानंतर गुगल फॉर्म ओपन होईल आणि यू हॅव टू अपेअर फॉर दॅट पर्टिक्युलर टेस्ट. ओके, काही डाऊट असेल त्यामध्ये Moodle मध्ये, यू कॅन अप्रोच टू मी and I will provide the question bank also. So any doubt in unit number 1? Unit number 1, losses. Important points are losses in pre-stress. Second, methods of pre-stress. These are the 2 important points from the unit number 1. Then also stress calculations, analysis of pre-stress. ठीक आहे, हे झालं असणार आहे तुम्हाला. झाले का ते पण रिवाइज करायचं आहे? युनिट नंबर 1 कंप्लीट झालाय ना?
हो सर,
झालंय ना? ओके. डाऊट
रिवाइज करायचं.
रिवाइज करायचंय. ओके. So we will arrange again one or two sections. So to revise the unit number 1. Okay. So simultaneously we will do that. काय करूयात? Unit number 2 simultaneously as per timetable it will be continue. And for unit number 1 I will take 1 or 2 lectures for that revision. आणि आपला जो फोकस असणार आहे, आता सब्जेक्टचा फोकस कसा असणार, मी कसं शिकवणार? सो मोस्टली इट विल बी PPT फर्स्ट अँड फोकस विल बी ऑन द कॉन्सेप्ट. पूर्ण प्रॉब्लेम घेत बसणार नाही. कशावरती फोकस असेल? बेसिक कॉन्सेप्ट, बेसिक फिलॉसॉफी. ठीक आहे. आय विल बी फोकसिंग ऑन द बेसिक कॉन्सेप्ट, बेसिक फिलॉसॉफी. द मॅक्झिमम फोकस विल बी ऑन द MCQs. So all different examination, I will cover your MPSC, UPSC, your SPPU. SPPU चं तुमचं ऑलरेडी कव्हर होणारच आहे. दॅट इज नॉट अ बिग डील बिकॉज द लेवल ऑफ क्वेश्चन्स you will expect in SPPU that will be at much lower level. So getting a passing mark and good marks, that is not the issue that you will get, but we will covering all the question papers or the objective first from GATE examination point of view, then for MPSC, then for UPSC. त्याचा काहीतरी तुम्हाला उपयोग झाला पाहिजे. So just studying this subject, getting passing marks, that is not sufficient. And after your graduation also, जेव्हा तुम्ही जॉब करायला जाणार आहात बाहेर, जे स्ट्रक्चर तुम्हाला डील करायचे आहेत ते प्री-स्ट्रेस स्ट्रक्चरच आहेत. ब्रिज असेल, तुमचं शॉपिंग मॉल असतील, मल्टीस्टोरी बिल्डिंग असेल, पुण्यामधलं आता फिनिक्स मॉल असेल, वर्ल्ड ट्रेड सेंटर जे आहेत